Hello, Internet, and thank you very much for tuning into the Cloud Native FM podcast. This is your co host for this show. My name is Saim Safdar. I am a CNCF ambassador, and joining me today Eyal Bookchin from Metal Beer, and we will be speaking about very shortly around Kubernetes, remote Kubernetes development. But let me give you a very small description of what we actually have planned for today, as a little bit of story that you actually get better understand the things we're speaking about. Setting up development environment can be daunting, especially for large systems. While configuring tools like VS Code, Docker, or local Kubernetes cluster may seem straightforward, the real challenge lies in managing dependencies beyond the application itself. So developers often find themselves overwhelmed by the need to maintain numerous dependencies locally, from backend application to databases, messaging queues, and more. And continuous updates and change to these dependencies further complicate the process, leading to wasted time and effort. And today, we don our developer hats as we embark on a quest for a perfect solution, and our search landed us to mirror.dev, an open source tool that lets you run a local process in the context of a cloud cluster as if it was running in the cloud itself. With that, let me go straight to Eyal Bookchin for giving us more insight to this. Over to you, Eyal, and give us a little bit of introduction of yourself first.
First of all, thanks for having me, and thanks for that fantastic introduction. So my name is Eyal. I'm based in Tel Aviv, married with one baby and one dog, and I am the co-founder and CTO of Metal Bear. As you said, we are a dev tool company where we build dev tools for engineers, or at least that's our vision. In practice, we have one flagship product called MirrorD, which dramatically shortens dev loops for cloud engineers. And that's going to be the subject of our talk.
Thanks, absolutely. And I will share the link with the folks who actually recently joined us. Here is a link to explore the mirrord.dev open source project. I also included some of the links for your reference to actually go and watch some of the documentation of the project, some videos on the internet, and some blog posting as well. But let me straight, because I am one of those person who really try to understand how this project actually came into being. So, my question first for you: what challenges were you addressing that motivated you for the development of MirrorD, an open source project?
Yeah, so my co-founder and we met at our previous job at a company called BioCatch, which does fraud detection for financial services. And BioCatch has this huge cloud architecture, high scale, etc., and it suffers from a common problem of successful companies, which is it has a lot of customers, which entails a lot of different data in production, different states, different incoming traffic, just very weird conditions that your code can meet in the production environment. And so what would happen is, devs would write code locally on their machine. They would test it in internal QA environments, and finally reach production, but often, face these huge issues simply because they had no way of replicating these conditions at any step before. And so as sort of an intermediate step, Bellcat set up this amazing staging environment where they put a lot of work into making it as similar to production as possible. But it was this one environment, right? And everyone wanted to use it. So it became this huge bottleneck. And so now this became the problem. So you had this great testing asset, but you could barely use it because you had to wait your turn, and turn could often last hours, maybe a day, because you'd want to once you reach staging, you want to make the best use of it. And so that's the problem that we try to tackle with MirrorD. And when we thought about it, we thought what would be the best way to use a staging environment? What would be the best way for me to, as a developer, to be able to test in the cloud? And the answer we came with is just the same as they test locally, right? Like, what if when I click the bug in my IDE, instead of running in some local environment I set up on my machine, I would get the context and conditions and database state and third-party API access that they had on staging, right? So that was a motivation. To be honest, I'm saying staging, but initially we wanted to do this for production environments, and we were quickly shot down in the comments of Hacker News and Reddit that no one would ever adopt something like this for production. We're yet to see, but for now we're focusing on staging, which we think is definitely a good enough step in the right direction.
Yes, absolutely. And I think if people were listening to you, I'm looking forward to see how people react to this project. And please share your add some question in the comment section as well. We look forward to it. So I think that, as you mentioning, the story is kind of a similar from my background as well. When I developing, I think in some 2017, 2018, we have a very big systems, very monolithic giants app, and we have a development environment, we have a staging environment, we have a production environment, and the things will never ever we ever be resonate when the bug arise in the production. We don't know what's happened there because the development environment is completely different, and somehow we don't have this kind of policies or restrictions of accessing the production like environment, and we were always fighting with the DevOps engineer. I need to investigate what happens there. So as of today, we have tool like MirrorD, which basically promises us to mirror the traffic coming into the production cluster and then actually serve that traffic in locally, so you able to give a sense of how things are actually going bad at that step. With that, I think some people are really new to the MirrorD open source project. Might be this is their first day of learning about it. So let us give us a walkthrough of what is MirrorD and what feature we can opt for today.
Yeah. So you mentioned mirroring traffic. The name of the tool is MirrorD, and I think that was our worst mistake because people end up thinking that's the only thing it does. And that was really, that was our first feature. Initially it was just this VS Code extension that would mirror traffic from a pod in staging, incoming traffic to that pod, or a pod in a remote Kubernetes cluster to your local process, and that solves some problems in its own, right? So sometimes you just want to see what remote traffic looks like, see how your process handles it. But more often than not, you want to test like real complex flows. And when I say complex flows, you want to see how your process handles environment variables from the remote cluster, how it handles files from the remote cluster. When it sends outgoing traffic, you want it to hit the destination in the remote cluster and see how that behaves. So all of these things and a few more are basically the feature set of MirrorD. What we basically try to do is cover all of the entrance and exit points of your local process and make them work against the cloud instead of locally. So that when your process runs locally, it thinks, it's running in the cloud. So that's what the MirrorD open source project provides.
Awesome. So I think I can absolutely. So now I think because this is an open source project, people want to hear about more of the use cases it's support today, and they wanted to hear from you. What have you seen? People have been using in what are the different places? So, and then in short, when and where to use MirrorD in open source as open source project.
Mhm. Yeah. So I think the most trivial use case for Mirrord is where you would once test in staging. I mean, let's go over like the traditional development cycle, right? So you test or you code locally, you test locally to the best of your ability, and then you usually go through CI/CD, which has some more automated tests. And then in a lot of organizations, your code reaches staging where you perform some more end-to-end tests there. And so the most trivial use case for Mirrord is just to replace that last step, right? So um, uh, instead of deploying or going through CI and deploying to staging, I could use Mirrord after I did all of my local testing and I went through CI just to do that last step, right? And that provides some value right there. But what a lot of people miss is that Mirrord, in addition to letting you quickly iterate against the cloud environment, it also lets you non-invasively do it, right? So you can test against this cloud environment without affecting it. And if this is a shared environment like staging, then that's meaningful, that's significant. And what this also lets you do in terms of use cases is bring staging in a lot earlier in the development process, right? So you can shift left on staging and essentially start leveraging it from step one. You never really have to run your process, locally like you used before, because you can use the cloud from the outset and save time that way. So these are the two main use cases of the Mirrord open source. There is also a use case for CI/CD because if you can non-invasively use a shared environment, then a lot of automated test suites that spin up and tear down environments, which takes a lot of time, often cloud costs, they can instead use the shared environment. I think those are the main ones.
Yes, absolutely. So I try to highlight some of the things we have discussed today, so I can able to understand that is my understanding of is my understanding correct about Mirrord after listening to your talk as well. So when developing an app, the real challenge lies in managing all of the interconnected component surrounding it, from backend to front-end application, databases, message queues, and caches, and the list goes on. So maintaining all these dependencies locally can overwhelm our laptops, leading to performance issues and constant updates. So it's a continuous process. So that demands significant time and effort. So rather than you are focusing on your app, you are focusing on these complexities. So our energy should be better spent on actual app development, not on the complexities of running the local development environment. So with Mirrord, your local application mirror its counterpart running inside the cluster seamlessly. So I think one thing while I tried running Mirrord today is that its beauty lies in the ability to ensure that our application, our local application, doesn't disrupt the system whomever else might be using the application. So might be the application running inside the cluster have other user using it, but those are oblivious to the fact that you are running a local version of it. And by deploying an agent within the namespace, Mirrord intercepts and redirect all the traffic from your local application to appropriate service. So basically, Mirrord is effectively allow you to work locally while being connected to the rest of the system. So is there anything I missed before I move on?
No, that was pretty spot on. I think the situation you described at the beginning, of running everything locally, but it costs you performance and uh, your laptop is on fire. I mean that's the best case, right? Because for a lot of organizations, running everything locally is it's a non-starter. Like you're just not going to be able to do it. And so what you're left with is a shared environment that you have to deploy to. So you go through all this process to make sure that it's safe. So you do all your testing locally, and then you go through CI, and it takes a couple of iterations, and then finally you do deploy your service to staging, but it's still new code, right? And you've replaced the stable version in staging, so you're in there's a good chance you're still going to be affecting the shared environment. So as you said, what Mirdi lets you do is cut the time it takes to reach remote cloud environment, staging in this case, and b just use it non-invasively, so without affecting anyone else working on that environment.
Yes, absolutely. I think that's the feature I really like about it, because once you actually access the, let's say, the pre-production traffic, and three, four other members of the team is using the same traffic. So sometimes it's very difficult. Like it's some bottlenecks came up. So the mirror D is actually allowing you. So because other team members don't need to be worried about these the cluster inside happening in your local cluster as well. That's the part I really like about it. Now I notice some of the limitation of an open source project. I do see some of the community have asked about, or like, if you in today's please correct me if I'm wrong, in today you actually have only one pod agent with that cluster is running, and that agent is actually intercepting the traffic and mirroring back to the where your local development is. So it just only a one pod, so you can't actually scale beyond that. So, and
Mm-hmm.
people say this is too limited for the scope for testing. So, but I wanted to learn from you, like, what is actual limitation of open source mirror D is, and how do we overcome that?
Yeah. So I think it's a good time to briefly explain how Mirror works, right? So um, it has a client which we call the layer, and a component that runs in your cluster, which we call the agent. And what the layer does is it injects itself into your local process, and it overrides all of your input and output syscalls, right? So file reads, incoming traffic, outgoing traffic, etc. And then if you take, file reads, for example, when your process tries to read a file, the layer intercepts that call and sends it to the agent running in your cluster. What the agent then does is read the file from, we call it the target pod, the pod that you want to use for your debugging. So it reads the file from there, sends it back to your local process. So the process has received a remote file, it doesn't know. Like it just ran the file read function. And the issue, with the open source, or not the issue, but the limitation. So all of this is standalone, right? So the layer itself, when you start a Mirror session, it creates the agent, and then when the session ends, the agent is cleaned up and is gone. It is not aware of other instances of Mirror running in that same cluster, which can lead to clashes, right? And so on a higher level perspective, what we were trying to do with the separation between open sources and commercial is for the open source to fit either individuals or people wanting to try out Mirror, see if it can work for their team, and then the commercial project to work for organizations, for teams ready to try out properly or adopt Mirror across across the organization, and it works technically as well, because that's what the commercial version adds, a control plane that synchronizes between different instances of Mirror.
Yes, absolutely. So I will try to highlight some of the things here, because people who might be joined late actually have some questions. So as of today, actually, if you have, let's say you're developing locally and one of your services running locally, and the other services, let's say the backend is actually in the cluster, and you want to access that backend that's running inside the cluster, with mirror D, you can actually mirror that traffic coming in the inside the cluster as if it actually running in your local system. So with that happen that able to be accomplished, mirror D runs an agent. So basically what's happening inside every system call goes through, that agent actually have a namespace and has a pod associated with it. If that pod is actually belong to the same name safe space where the agent is running, you can able to collect the information and then mirror that traffic into this stuff. Now the next feature, that's where I think we can actually people try to understand where the commercial and want to learn more from you is when you have more than, let's say, more pods or more replica set or more, that's where you need mirror D for teams. And
Yeah.
that mirror D for team is basically runs a Kubernetes controller inside the,
Yeah.
and then you basically all the team members basically have a collaboration sync. And how the controller, like, is the controller that the mirror D for team is running, is it a responsibility of the people who are actually using that, or is it that you are actually making sure the patches or upgrades or all those kind of stuff?
hmm Um, yeah. So as mentioned before, we have MirrorD for Teams as this controller, which we call the MirrorD operator. And what it does is it synchronizes or orchestrates between different instances of MirrorD. The MirrorD open source is standalone and it's transient. So when it finishes running, it deletes itself from the cluster. The operator, on the other hand, is a persistent component that runs in your cluster, and it's usually the responsibility of an admin in the organization, right? It depends on who holds that role within the organization. It's not a lot of administration work, but of course, someone has to be responsible for it. And that's another place to mention that MirrorD and MirrorD for Teams are completely on-prem, right? There's no communication to an outside cloud. So the flip side of it is, yeah, you have a component running in your cluster, and we don't know if it breaks. Um, so that's about the operator and whose responsibility it is. And just to understand what it actually accomplishes, what it provides on top of the open source, right? So we try to think what would teams using MirrorD or mature organizations using MirrorD need, right? So the first thing is obviously just being able to concurrently use MirrorD on the same cluster and even on the same service. So that's one thing that the operator accomplishes by if you're trying to use it on the same service, you're just going to have one agent as opposed to multiple agents with the open source, and there's no duplication or misdirected traffic. Second thing is around security, right? So the MirrorD open source, as you might have figured, needs permissions to create a pod on your cluster, right? So if you're using a staging environment in a large organization, that's often not a permission that you want to give all of your end users, right? So now the operator is the one that does this, and the end users only have permissions to communicate with the operator. And on top of that, of course, you can control exactly what they can or can't do using roles and permissions. So that's the security part. And of course, there are some advanced features that can only be implemented using something like the operator. So one of these features, for example, is using your Diana deployment with a replica of more than one. So if you have several pods all receiving traffic and you want to receive all of that traffic, you're going to need some centralized component to aggregate this traffic, send it to your local process. So that's another example, and of course there's more.
Yes, absolutely. So I think like we covered two different things, and might be some people are really confused
Okay.
how these tools are different. So in short, there's a Mirror D as an open source project they have some very cool capabilities because I like it. I have spent a lot of the time in the development, running in a pre-production like environment and debugging and troubleshooting. It's make a lot job a lot simpler because you don't need to actually customize or configure or install or manage all of these third party services locally just to spinning up your application. Might be you actually working with a login authentication app, and that app is actually working on with three third party application. So in order to work with them, you either can actually host those all third party services locally, but that your laptop bursts out because of Kubernetes heavy loading. So for that, you need a mirror as open source project. It has some cool capabilities of mirroring and traffic stealing as well. And then it also has a feature like you can actually add a header in your mirror send request. So it's basically tells like this traffic stealing is just for me, not for anybody else in the team. Now, in order to have more than one pod, you have a sophisticated setup. That's where the Mirror team shines in. So in Mirror open source, you have privileged containers. Everybody can access the container, has root privileges, not a security by default. But in Mirror for teams, we have a Kubernetes controller that's only have permission that required to run those pods. It's basically a security built into it, and bunch of other really cool feature that I added in the LinkedIn description to highlight because I think Eyal actually added a video on Mirror YouTube channel of the recent releases of Mirror for Teams as well. So that's where you'll be spending a lot of time for organization and get a large setup or having a very sophisticated dependencies. So they go for the Mirror for the teams, and it has a bunch of other capabilities as well. And it's required us another podcast to actually showcase all other stuff as well. So with that, I think we cover the ground of both of two basic pieces. And if folks has more questions associated with it, let us know in the comment as well. But I want to know now you the next 10 or 15 minutes what we have, is learn from you what are does what are some of the Kubernetes challenges developer you face or you heard from them when working with remote Kubernetes cluster today?
Yeah. um, yeah. So I think we touched on a few before, but yeah, there are obviously a lot. A common one is that you can't properly debug, right? So in order to get your code running on a remote cluster, then you usually have to containerize it and then deploy it to the cluster. And this adds a lot of iteration time. So if you wanna, make quick changes, test them out, then every time you have to Docker build and deploy, Docker build and deploy. That that sums up to a lot of time and can be really frustrating. Um, Another thing is that if we're talking about personal remote environments, not even shared, so this adds another sort of scope of responsibility to the developer that they're not necessarily interested in, right? So I know it's like this a continuous debate about should the developers know about Kubernetes or should it be abstracted from them. And I'm with the second camp that says like the abstract that you can, because if you can, then it frees up cognitive load to for other stuff. Um, but yeah, so that's another issue, right? So another developer has to be able to debug Kubernetes issues, fix them in their environments in order to do rote day-to-day development. And then the flip side of this is for shared environments, they're just not really self-sufficient anymore because now there's an issue. Then they're usually dependent on some centralized DevOps or SRE team, so that adds another dependency, which of course affects their cycle time. So that's just a few that come off the top of my head.
Yes, absolutely. I think these can easily be predictable. And I think you mentioned, like, should developers learn Kubernetes or need to understand the intricacies of Kubernetes? There's still a debate. And that's debate lead us today to our platform engineering discussions. Like, there's a one team on setting everything for the app developer teams. So they actually focus on the stuff that business required for them, or not actually spending cognitive load or reducing the cognitive load from the developers. So we actually work most of the time on making sure the features of the things actually going to the customers have enriched capabilities in it without actually worrying about how this thing is actually built internally. So I think the next few more question, and I will jump into the comments if CSO folks have questions on it as well. I think we highlight some of the how does Kubernetes development contribute to team collaboration and productivity, and what you have seen while working with some customers or community, how this collaboration enhance the productivity of the feature development.
Hmm. Yeah, that's a really good question. So I think one syndrome that it sort of eliminates is the works on my machine syndrome, right? Because now that everyone's working on essentially the same machine, then it becomes a lot less frequent, and we're in a lot of ways just speaking the same language now. So I guess that's one thing. Um, and I guess another way to address this question is not how it contributes to collaboration, but how it stops hindering collaboration, right? Because when we're sharing an environment in the I guess the old way, um, then we're gonna step on each other's toes.
Yes.
So if I deploy a broken service to a shared cluster, I affect your testing, etc. Like it's obvious, and it brings in friction and frustration. And by removing these issues, then yeah, I guess you could say that it contributes to team collaboration.
Yes, absolutely. I haven't seen a comment in the YouTube, but I see a one message, one question in our Discord server today. And someone is asking, he says, like, is there an ability for mirror and vCluster to combine some of the capabilities to boost our productivity? So the question around vCluster is actually is a component, is an open source tool that gives you some nested cluster inside the cluster, so you have ownership to run those apps on top of it, and then you can actually intercept the mirroring traffic from that cluster from mirror to intercept it, and then you actually developing app locally. Do you see any use cases being actually people being using mirror with conjunction of some other tooling?
Yeah, that's a great question. I'm only slightly familiar with vCluster, and I'm going to answer in terms of use case and technically, right? So in terms of use case, of course, like whenever you have a remote cluster that you're working against, whether it's a shared cluster or an isolated cluster, then MirrorD can help because MirrorD improves the development experience when working
Yes.
against a remote cluster. And so there's definitely a case to be made for collaboration there. And it might even just work, to be honest. Like I'll have to do a technical deep dive, but in a lot of cases, just trying to use MirrorD on this sort of tooling, it works. So
Yes,
I
I
think it's
think
worth
my
a try.
absolutely. I think that's a great question, and I think I my initial guess it works seamlessly because the V cluster is actually running two type of cluster Kubernetes distribution today, like K3s or K0s, or might be some other in the cloud. So as soon as the mirror is there is a Kubernetes cluster in it, and that mirror is a component is basically who's go into that cluster, who can understand and speak the Kubernetes construct and mirror out the traffic. So it works seamlessly, but it's a very good use case and a potential collaboration with that community because the people are using vCluster today to nested the control or cluster, so they can install more stuff on it, trying and testing purposes without actually being freaking out or destroying or actually replicating or feeling or polluting the main production environment. So then this mirrored works on top of it, steal some traffic out of it, then you work on it. So basically it's a developer heaven, I guess, if people should try it. I want to learn more from the folks who actually experience that kind of a use cases as well. But it's a great
Yeah,
question.
Mirror is only remote dependencies, the Kubernetes API. So if vCluster exposes it, then it should be fine. And
Yes,
very
absolutely.
interesting, of course.
Yes, absolutely. Just a final question, because I happen to live in those kind of environment a lot, and that's why I added this question. How does remote Kubernetes development support multi-cloud and hybrid cloud strategies? Is basically the team who are developing application on more than one cloud.
Mm-hmm. Yeah, so the nice thing here is that tools like MirrorD really don't care. All they care about is the remote process and the remote pod. And if that pod is running on, GCP and communicating with AWS, that's communicating with an on-prem data center. It simply doesn't affect it, right? So and I think that's in contrast to tools that, for example, try to replicate your entire environment on sort of a personal scope, right? And they might run into issues there. But yeah, because MirrorD's scope is so small, so just local process, remote pod, then things like that, or even smaller, stuff that's running on your cluster, service mesh, weird components and databases that we've never heard of before, it's just not affected. So.
Absolutely. As long as I think, uh, as you mentioned, like it's just a system call, and if the stuff is happening on the cloud or on the Kubernetes cluster, but the mirror D is actually talk to that APIs, installing an agent, and then mirroring and stealing the traffic from it. So it not need to worry about what cloud provider it is, but it just need to understand and to able to understand the APIs of Kubernetes to be able to communicate with them, and then do the heavy lifting and making the shortening the loop for the developer so they can actually access the cluster locally and as if it was running in the remote Kubernetes cluster. So that's not a big issue, and it's a good idea, good news for actually a lot of the developers actually developing apps in different. I think that's where the mirror D really shines for my eyes, because if you're working on the multi-cloud environment, some of the application and the services running in the cloud, and without those services you can't test out the functionality you are developing, because your whole application has many microservices today. So instead of running everything locally, this is a disaster for everyone, because you can't do it. Because every time you run out, let's say if something database is actually updated on the production cluster, then you need to update the database, or the schema is updated in the cluster in the database. You need to update locally. So it's a lot of the tough for the a lot of stuff for the developer if they do so locally. I think I don't see any reason of not using the mirror D, but the question of how much the feature you want to use for mirror D. So does open source work for you? If not, the mirror D for teams actually basically a good fit for a lot of the organizations today as well. So without I'm wrapping up, I will get a call to you to wrap everything up for all the viewers who might join late or still have some questions or misconception or misunderstanding some or some skepticism around some of the tooling. So your key takeaway. So Eyal, three key takeaway on remote Kubernetes development.
Ooh, that's interesting. Um, so I think the main sort of misconception is that it might be legacy, right, or sort of a dying category, because it has been around for some time. Telepresence has been carrying that banner for quite a few years successfully. Um, but there is a lot to be improved. There's a lot to be done there, and the promise of being able to really to have staging on your local machine without affecting it, it's a tall order, which at the current state, MirrorD does not fully fulfill. I think we're the best at doing that currently, but it's only going to get better. I think we're going there um, as an industry, right? As a space. So one reason is of course there's a lot to be done to improve it, but then the other is that um, the alternatives. Replicating environments. Um, they're gonna run into walls, either complexity walls or cost. Um, because environments are becoming more complex and more varied, and more components are being integrated within them, and so that's going to pose a challenge for this other category of tools. Um, so we can count that as two takeaways, I think. Uh, what's a third? Yeah, I'll stick with two. Nothing comes to mind.
Yes, absolutely. I think these actually will be. I think that the category falls, as you mentioned, like how well my remote, how I can talk my application to the services running in the cloud, and how those services discover my application running locally. So that's where I think the category comes into the lie as well. And I think the third might be is how much of the pain you will be actually going through setting all this up. With MirrorD is not just any pain. It's just a VS Code extension or JetBrain extension. And you can set up a breakpoint and then you start debugging and running or troubleshooting locally. So that things I like about more. So
I have
I
I
will go
have one
to,
more. Can I say it? I have my third.
yes.
Yeah. So I think as the technology improves, then it's going to spread to other parts of the organization, right? As the staging environment becomes something that can be used, without concern, that it's going to spread obviously, to QA teams, but also to product teams and to sales teams. Because why not? You have this, great production replica that you can use without affecting it. So. Yeah, that's I think that's the direction we're going.
Yes, absolutely. I think one thing I really I think the sales area is kind of really heavy because sometimes you giving them a demo and you hit with some walls and the production demo flaws away, and you don't want to set up another meeting with a client. What you can do is you troubleshoot in a few minutes within for the sales executive team, and then set up a call for them. So it's not just a full loop or the ticketing in the Jira for the developer to fix things up for the sale representative folks to set this up. With MirrorD, you can do so instantly with the help of the developers who are actually being responsible for that feature. So that's where you can really kick off your sales more often than not. That I see a lot of the pain in a lot of the companies. I definitely see this might be the way we're actually heading towards too. But I will conclude with some of the my learning here as well. So with my understanding today, as of running locally today and working with it for a last 3 4 days consistently, with MirrorD, your local application mirror its counterpart running inside the cluster, and the beauty lies in its ability to ensure that your local application doesn't disrupt the system. Whoever else might be using the application running inside the cluster is oblivious to the fact that you are running a local version of it. And by deploying an agent within the namespace, MirrorD intercepts and redirect all traffic from your local application to appropriate service and mimicking the behavior as if it was running within the same cluster. And mirroring is one of their feature. Mirror stealing traffic and security on mirror for the team is really shine. Web browsing session copy target, and one of the recent very great new feature is around pause container that I'm actually exploring today. I want to learn from more folks as well. With that, thank you very much, Eyal, for joining us. And folks, we will be giving a deep dive of some webinar on my another YouTube channel with the same team, with new folks on Cloud Native Islamabad. Might be next month or this month, but I'll let you know as well how this works in a hands-on way. With that, thank you very much for tuning into this channel. We will be covering another episode with a few days from now and coming back on the panel talk on platform engineering on May 29. With that, have a wonderful day, everyone. Stay safe, stay happy. Bye bye.
Thanks, Sam.